We are going to the next part of the program. This is actually a panel discussion. It's a very timely topic. The topic title is In the Era of Digital Trust. We are privileged to have today members from industry, government and enterprises, public enterprises. So this is actually going to be each of the presenter, at least two of the presenters are having a presentation with them. So they will have a presentation and then couple of questions from our side to them, and then they will be opening up for further questions from you. So this is the format in which we are planning to organize this session. So with this, I would like to welcome Mrs. Hemavathy Madam, General Manager BEL, to the dais. As Madam walks, I will read her profile. Mrs. Hemavathy is currently leading the Network and Cybersecurity Strategic Business Unit at BEL Bangalore since 2024. Prior to this, she was working as a principal scientist at Central Research Lab and heading Cybersecurity and Crypto Research Systems Group at BEL. She has received her Master of Engineering from National Institute of Technology, Trichy, and is serving BEL since 1997. With 25 years of R&D experience at CRL of BEL, she was heading Cyber and Network Security Vertical and has contributed as Security Architect and Designer in the network and cybersecurity areas for various C4I programs of the Tri-Forces like BSS, ADC and RS, CIDSS, ACCCS for Indian Army, IACCS for Indian Air Force, and had largely contributed to the indigenization of various cybersecurity technology and solutions. During her tenure at CRL, she has headed successful programs of security certifications, especially the Common Criteria EAL4 certification and the DRDO SAG certification for various hardware and software-based defense security products for BEL. She has published around 20 papers in national and international conferences in the area of cybersecurity and holds 4 patents to her credit. She is a recipient of Honorable Raksha Mantri Award for the design and development of Citizen Card Verification System and BEL Key Contribution Award for her work in network and cybersecurity for defense forces. Eminent Women Engineer Award by IEI, Bangalore Chapter in 2023, and Outstanding Cybersecurity Women CSI Bangalore Chapter in 2023. We welcome you, Madam.
Present here and one and all. I thank CDAC for giving me a wonderful opportunity to share our views about this in this particular forum on digital trust, and I would like to emphasize on indigenization of the hardware so that hardware root of trust can be established. So with the advent of Web 3.0, which is promising connectivity and digital trust across global, and emphasis is on the P2P kind of communication and decentralized network, so that we would be having complete control on the data and privacy. So technologies like blockchain is largely adopted to ensure this sort of communication, and it enables us to secure and have a tamper-proof transaction among each other, as well as the data storage. The concept of zero trust architecture is also increasingly adopted, wherein the traditional VPN kind of secure remote access is being discouraged, and concepts like ZTNA is largely being adopted, which can enforce access at the device as well as user level to application as well as the user level. It also enforces least privilege access, so that the control is very much minimized, so that the particular access and particular resource is available only for the authorized person. Apart from that, we need to ensure that PKI, like the last 2 days of deliberations and discussions and presentation was centered around PKI, and that is going to be heart of all of these technology, so that non-repudiation, authenticity, integrity is always ensured, and it is also it is also the concept non-repudiation ensures in the in law legal aspects also, which is going to be an important attribute which has to be met with. And AI anyway, there's everywhere AI, and how do we bring in concepts of AI in adopting PKI technology is another area we'll have to focus upon. Apart from that, we all know it is not only digital, the physical supply chain, it is now the concept is digital supply chain, wherein we don't have any control how the third party has its security in defense in depth layer, how these security controls are adopted. And we are relying on third party with the advent of cloud and other security software as a service or a security as a service. If it is an internal environment, we do know what sort of defense in depth is been adopted and what are the security control and authorization we have given in accessing a resource. So cloud and AI has large impact on this, and how do we address them? And the advent of quantum computing, like Dr. Vishal also covered, how we have to gear ourselves to migrate to these technologies. So broadly, these are some of the areas which has to be addressed. But my focus would be on emphasizing on the need for indigenous hardware security. So, hardware security is nothing but it provides a reliable platform to execute software for a desired application. So, indigenous hardware security will enable a national level security also, so that backdoors can be avoided, as well as the surveillance of the foreign entities or other non-friendly nations snooping into our communication or our systems or networks. And another important aspect is that we have self-reliance and the complete critical technologies. If it is indigenized, it is going to be, IP is going to be relying with us. And major global threats, cyber threats was also listed out, which has been covered by other speakers also. So these are some of the protective measures of hardware security, which also got deliberated in these last 2 days of the conference. Secure boot is again, it verifies the hardware and the firmware stack by establishing the chain of trust, and it also ensures hardware root of trust as well as bootloader verification, and ensures that the complete stack is non-tampered. Again, TPM concept is also there. Trusted execution environment, like you have a TEE as well as the other portion, the open OS portion also, REE and TEE, wherein these features are being adopted by the microprocessor at chip level, and ensures that the integrity and other security aspects are maintained within the processor. And it is there is no possibility of a malware or a tampering happening in these critical section. Apart from that, HSM, which allows us to maintain lifecycle management of the crypto keys, physically unclonable functions, which are again ensures a digital fingerprint which can be used to authenticate any kind of device, and largely being used in IoT devices. And tamper resistant circuits and packages, if you see whatever encryptors we supply to our triforces, we need to have a tamper resistant and prevention circuitry, so that it is not, if it is falls in a adversary hands also, they will not be able to utilize anything out of it. So this is about the hardware impact import across the globe. If you see 89.8 billion USDs of electronics, telecom, as well as electrical products are being imported, and majorly from China and Hong Kong. We are also aware of the pager attack which has happened last year, and how Israel was able to conceal explosive in batteries of the pager, and it is so advanced that it was virtually undetectable also. So these are some of the disadvantages of the import also I've tried to bring out. Like you see, the sovereignty as well as strategic autonomy is under stake, and there's a possibility of continuous surveillance, the CCTV cameras and the networking appliances like switches, routers, and other servers also which are being imported. So there's a like if sanctions are there, then again we are at a risky scenario in emergency situations like war, and we will not be in a position to have access to the technologies. So restrictions could be in any of these categories like material, tools, components, or a TOT, or a sub-module, or any kind of financial restrictions also. So this slide just brings out the perspective of government, which is largely emphasizing on Atmanirbhar Bharat and self-reliance. Lot of funding in disruptive technology as well as critical technology is being allocated by the government, and a lot of startups. There were around 160,000 startups which are being nurtured in last 3-4 years, is what is the statistics which is telling. And so employment opportunity is also growing up, and economy is going to improve, and we will be saving the foreign exchange also. And if we have a good presence in chip market also, where government is doing a lot of focus these days to enter into semiconductor manufacturing also, we will have a edge over the complete ecosystem. From industry perspective, if we have our own technology, we can better manage obsolescence, and also customization requirement for specific deployment, be it a mission critical network, wherein you can have a completely customized example. An operating system can be completely customized and deployed for a closed group deployment in case of defense specific deployment, and also cost saving and profit improvement if it is in the mass scale produced. And the complete knowledge of design, implementation, everything is going to be with us, and the IP is hence protected. These are some of the challenges. Again, what is the kind of market potential we will be able to acquire, because there are a lot of competition across the globe, and the presence with FDI, the presence of many global company is very much in our country. And then how do we cope up in such a competitive market scenario? Again, we need to see how government will facilitate with respect to Make in India product adoption across various sectors. And other aspect is the competency and expertise in developing these technologies is another thing which has to be parallelly looked at, and the policies which government enables us to facilitate to adopt this sort of goal, self-reliance goal. The approaches is, as I told, Make in India policy, and establishment of IC fabrication as well as design industries. With the advent of PLI scheme, it is largely coming up in our country, and we should have a long-term sustainability plan also, and documentation and other moderation of the IP restrictions with respect to patents and copyrights. So at Bell, this slide just covers about the activity we are doing, and what with respect to PKI and cybersecurity technologies. We do have a in-house PKI token which has been offered now for CCA audit also. We developed it based on an EAL4 certified microchip based PKI token, but complete firmware and other modules are in-house written. The RA and CA stack is also in-house developed, and we are going to offer for CCA certification. We do have blockchain framework and some of the smart contract application we have developed for our Triforces. Quantum safe RA and CA development is in our roadmap, and development is in progress. Post-quantum based hardware encryptor is also one of the product which we have launched. We do have in-house quantum key distribution, and with respect to PK, the e-sign framework, we collaborated with CDAC and we have developed that also, which we are offering to our customer. EL4 data diodes, because since we are handling with defense networks, the air gap between the intranet and internet is very, very crucial for us. And again, we have a product called as data diode. Again, authentication and other aspects, we adopt PKI technology over there. Apart from that, the complete security stack, we are having good presence, and for a closed group network, we are deploying our own solutions. So with that, my session is ending. Thank you all. If there's any question, I'm open for that. Yeah.
So thank you, ma'am, for the presentation.